Hello, everyone. Welcome to the working group serving orchestration workstream meeting. And today we are going to be focusing on Kserve. And welcome everyone from the Kserve project, especially Dan, Janu, and a couple of others from our team, Verdan and Juho. And Angie is also here from Kubeflow. Welcome, everyone. Clayton, do you want to get started?
Yeah, and thank you, Jan, and thanks everyone for attending. Jan and I had chatted when we were at KubeCon EU. Just for context for everyone here, like the observation that I'd made maybe for the last 6 months or so was there's an increasing demand for evolution of core Kubernetes to support scenarios on top. So there's a lot of frameworks on top that run really important workloads. We want to make sure that we have the right investment in that. Working group batch has been really successful at working with different batch frameworks and making sure that the primitives that were necessary in Kubernetes were improved, like jobs, but also the Q project, which attempted to raise one of the efforts to kind of standardize how time delayed batch frame could be used by multiple frameworks on top of Kubernetes. From a serving perspective, obviously Kubernetes was very successful with web applications, and over the years, projects like Kserve and others in the ecosystem, some of the ones we listed, like Kaito and Selden, all built serving for inference on top of Kubernetes. And then with the rise of larger and larger accelerated models, some of the limitations of Kubernetes became obvious with regards to accelerators are poorly modeled in Kubernetes. And so there's work going on right now in the device management working group to go, add as a first class primitive accelerators as they are today, and accelerators as we want them to look like in 5 years into the Kubernetes resource model. And so to pair with both working group batch and working group device management, we wanted to start a working group that would be focused on primitives in Kubernetes for supporting serving workloads, serving frameworks, and ensuring accelerators work well. And for me, the personal focus is on very large models, right? People deploying LLM at scale. There's a lot of people doing that, but also I want to go and canvas the ecosystem and look for things that we can improve across the board for serving, whether it's just web applications, whether it's inference, whether it's accelerated inference, or whether it's things that would make frameworks more effective. And so with the orchestration workstream, we were hoping to kind of start with Kserve because it's probably the most successful serving framework built on top of Kubernetes. And we wanted to take some lessons learned and get feedback. What could be improved? What are the primitives that might complement or better support Kserve? What would Kserve like to do less of so that it would have time to focus on more specific problems? What pieces of Kserve could we split out or better support at the lower level? Like, I'll leave that open-ended. And so I thank everybody for attending. Do you want to take us through the topics? Are there any other questions people have about why working group serving? Obviously, its goal is not to go implement Kserve. I want to make that really clear. That is not what the intent of working group serving is. It is to find primitives that apply to every deployment of Kubernetes and to make frameworks more powerful. So if you have any concerns about that, I want to hear them, because I think we want to make sure our charter specifically keeps us focused on improving the higher level frameworks. And I think y'all are a great example of somebody who's already been there down this journey.
Yeah, I think for Kserve to support these large language models, that's definitely the focus we have been on this year, especially for we are in the first half of the year, we are already spending on a lot of time supporting these OpenAI protocol in Kserve, right? That's the standard kind of the protocol people have been using across industry. So we would like to standardize on that. So as you know, K-serve already before like we are transiting from like the predictive like inference to a generative inference, right? And before like we have this like open inference protocol, which is good for general purpose like inference and for this predictive task, right? But that same schema doesn't like work very nicely with the generative AI inference tasks. So that's where we decided to adopt the OpenAI protocol. So which is like kind of like bridging the gap like for between like general inference and the generative AI inference. And in future we'll see like a more like a task specific like inference like protocol, like text generation and a multi-model like a kind of inference, those kind of things. Yeah, that's from the inference protocol side. And also another challenging like so we have been facing is why we like basically like rolling out like RMs to production, like that's especially auto scaling on GPUs. That's one of the biggest problem because GPU are very expensive hardware, and a lot of firms like struggling on like how can we efficiently and increase all the utilizations. Like we deploy this inference service, right? Because we have a limited number of like hardware, and then of course there's like power constraints. We are like limited. Even you throw the money, you can buy GPU, but like sometimes like even like for us, like we have like a consumed by power issues. Our data center cannot afford like adding a ton of GPUs, which obviously like put a lot of like pressure on our data center. So like the kind of like the how can we like the utilizations like for this like hardware and deploy our inference in the most efficient way. That's like kind of important. And some of the challenges like around like auto scaling is that is the code startup time, because RM like if you have like a model download from like this like S3 cloud storage, oftentimes like it take like 10 minutes plus. Obviously it's not good like for auto scaling, right? So that requires like we have been looking into how can we like serve these models like from like local volumes, right? That's the kind of based on our testing. That's probably the most efficient way to be able to quickly like spin up the container like via like by caching models on local like a PVC. And then there's challenge, how do you like, because like you have also like a limited like local storage, right? Like how many like a larger module we are talking about, you can like cache locally. And you might need to like divide the like have a node groups like caching different set of models. So that's some of the challenges we have been facing, like how can you replicate the models in. This is not exactly stateful like a service. It's like the state is like a models are like it's the same across the set of nodes you want to schedule on, right? We're trying to like build some infrastructure around like how can we like make serving the like deploy serving and deploy this large one easier. We can I think another challenge is the how what metrics you want to base on like to scale, right? And Knative so far like K-serve have been like being able to like scale the workload based on the concurrency or like the or the QPS of request demand, right? The request demand, right? But however, like for RMs, like often the time like you will need to because like each input may have like a different number of like input tokens, right? And different number of like output tokens. So allowing so the scale based on like request may not be the ideal way. So you might, based on our auto scaling like experiments, So we might need to go down to the token level, be able to scale based on the number of like inputs and output like tokens generated. So that requires like a kind of a different autoscaler, I would say. And you may also probably like a more complicated like a query like where you can like combine the constraints of like how much power is used and what's the GPU utilization combined with like a token like a number of tokens, be able to like efficiently scale up and down the inference workload. Yeah,
Dan,
I think.
Sorry.
Yeah.
Did you want to take questions, or do you want to?
Yeah.
You want to go through and then we can take questions after? Up
Sure.
to you.
Yeah. I think that's some of the challenge I can think of current. We plan to like tackle like I think some of the problem definitely can be pushed to the lower level, I would say. But yeah, I would like to see if what everyone's opinions on this.
Okay. Abdullah, do you have a question?
Yeah. Do you have some thoughts on the workload API? So Kserve have this, I think, inference service API. That's the main API that Kserve exposes, I guess, to express like, model deployment. Has this been like, how has this been received? Do you feel that it is too opinionated? Do you feel that it needs to change in some way or fashion? How should we enable, cases where we wanted to provide canned configurations, but at the same time allow customers or users to tweak things without just basically writing a full pod spec or being like at the two extremes? Either it's completely, abstracted, or the other extreme. If I want to tune something, then I have to do, a raw deployment or something a lot more that requires a lot more effort.
So yeah, I can add. So in current case of, there are two modes. One, as you said, you just need to talk about the model format and everything is taken care automatically. The other one is if you need heavy customization, then you have the container mode where you can provide container details and take it from there. So both are supported. And specifically in the inference perspective, since it is much more contained than training and other workloads, it is much easier to have the high level customization because we know there are popular frameworks and we know what to do internally, right? So it is much easier than your traditional training or the other workloads. In summary,
and I was going to ask a question here too. Jan and I had chatted about this at KubeCon about just adding new serving classes is expensive. I think maybe I'm over summarizing. So Jan, if I'm misrepresenting, just let me know. But like the pre-canned versus the container, when you go to the container level, you are losing you're losing a lot of the abstraction. How often do you have people looking for something in the middle? Like how would you handle adding a parameter to the inference server? Like when you think about, you've got this protocol in the serving class, or we've got the container. If someone asked you for a way to add custom volumes, if somebody wanted to add specific secrets, how does that translate in practice to someone at deployment? Are those problems that you don't deal with, or if you do, you say that those are out of scope for Kserve?
So it is a mix. So I don't have any hard numbers here, but it is built on top of Knative, right? So there is some of the restrictions that Knative has is applicable for Kserve as well. So all the fields are not customizable. which is the same case in Knative as well. So that's applicable in case of also. But in a typical deployment, what we aim to do is to have the high-level abstractions, and I don't see a major use case where someone would always try container, because we have all the popular model formats which are supported. Dan, if you can, yeah, please add. Yeah, we have. For example, we have been adding the Hugging Face and VLLM, etc. So from a user perspective, they are getting all this extra logic automatically with the model format support. Adding that in a container would be really tough for most of the deployment use cases. So from an inference perspective, it is always ideal to actually have a supported model format and put all the logic within that.
Okay, and so do people ask you to support different versions of the model servers? Like, is that some? I guess what I'm kind of asking is that high level representation as you add new serving classes, as you try to keep that higher level representation. Are you seeing, like, for the users that you're targeting, and maybe this is like another question, is like, what users aren't you targeting? You know, like I know of a lot of people deploying LLMs that are using, you know, just basic cube objects. Why would someone not use Kserve? Who prefers those higher level deployments? Like, just to help us get an understanding, because I think this is this is always a question of ignorance rather than we don't always know why everyone above or below uses different things. How would you characterize that user? Is it enterprises? Is it platform builders? Is it platform teams? Do you have people asking you to limit who is allowed to deploy these lower level frameworks, like, so that the teams don't have to? What are the what is unique about the users that that leads down these paths for them?
So I'll add my perspective, and Dan can add to that. So initially, when it was started, it was built on Knative, and over time there was a need for directly supported on Kubernetes, right? And that is where the road deployment happened road deployment mode happened in Kserve. So if you are not aware, so there is a mod which is called the road deployment, which is not dependent on Knative. So like, at least to me, it would be really great from a Kubernetes perspective if you and we have lots of advantages, to be honest, like when we are using Knative, right? Because as Dan was suggesting earlier, it has all the request level auto scaling and many other extra advantages. So ideally, in a road deployment mode, if Kubernetes provide better options to handle many of these are common challenges. I don't think that is specific to Kserve as such, but if we can actually provide that at the Kubernetes level itself, as Dan earlier suggesting, to actually push to a common layer beneath that, right? That will be really beneficial. And right now we have certain disadvantages or limitations in the road deployment mode.
Yeah, and then people want to use a raw deployment because, like, a lot they have like small teams that don't have the bandwidth to maintain like Knative, and adds the complexity. So that's what we hear, like a lot of like smaller teams don't want to manage Knative because it adds a lot like a complexity. I mean, like for companies like can afford to have like a platform teams, so they might be able to like manage Knative, but like a lot of people like probably. Yeah, and you have to like have this like a very complex support like a matrix, like different versions of Knative with Istio and then like Kubernetes, and you basically need to like basically have to figure out like these versions and whether they are compatible or not, and be able to because like upgrade Kubernetes itself is always like a a bit challenging for some of the people, but and then you on top of that we add like a Knative, and it's still then it's definitely like a burden for people. You need like a dedicated like platform team to manage that.
Certainly, that's I think that's a very productive question for like us to ask, which is, are there things that we could put in Kubernetes which would reduce your dependency tree for most users? Like that, like as Jonah was saying, like I think that's one of my thoughts is, how do we make it so that you have a lower, like what are the things that people might want to use for other reasons? Like they have a very opinionated way of doing model deployments and they don't want to use Kserve, but do that in a way that then everybody on Kserve benefits, I think is like a little bit of the pieces I'd be looking for. Are there other things like that in the workload API that are painful? Great one would be like extensibility of serving classes. We've kind of, Kubernetes is extensible in certain dimensions. What are things that would make serving class easier to support in Kubernetes would be like a great list of, because we've at least noticed that a lot of operators, frameworks, tools want to have variability in what they support. The raw extension concept has shown up in a couple of different frameworks, where you can just plug someone else's CRD in your object. Gateway took some steps towards improving like referential grants to solve one problem. What are some of the problems that y'all still have with serving class at a fundamental kube CRD level that we could actually go target improving that would make serving classes easier to implement or support, for instance? And if you don't have an answer right now, I mean, I'll just throw that out as like a potential follow-up topic.
I can share one recent challenge we have. Basically, when our users, when they upgrade their serving runtime, they want to carefully roll out the changes to all the deployments. So that's one thing we want to pay attention to, because we don't want to introduce like a lot of like downtime, introduce those additional parts, additional deployments. We want to make sure that upgrading process is affordable and secure.
I mean, that's definitely a problem I've noticed in other operators, right? Like almost every operator at some point goes through the question of, how do I reduce the risk of rolling out an update to the operator or the CRD or the backend logic or supporting proxies? And so I'll note that one, Abdullah.
Do you like in the inference service API, we have like explainer, transformer. Do we see those as still being necessary components of LLM serving? I'm just wondering, like, the reason I'm asking is I'm trying to look at if the Kserve API, because it's been here for a while, did it evolve in a way that it became more and more complicated? That maybe we should take a step back and see, okay, maybe there is a simplified one specifically for LLM serving, given that LLM right now is like the new hot thing, or we feel that whatever we've built so far, or whatever we have exposed in these APIs is still relevant for LLMs.
So just to add, for LLMs, we have tried to provide the same high-level interface that we have for the traditional models. So there is not much difference as such. If you are familiar with the Kserve model, like there's a model format which specifies the type of models to be used, and the corresponding runtime is something that user specifies. So even in the case of LLMs, we have few runtimes which can support the Hugging Face model format, for example. So there is not much difference as such. The current abstraction can hold the same set of LLM requirements as well. But to the other discussion that Dan was talking about, due to the model requirements from a purely from a model perspective, there are other challenges with respect to LLMs, but not actually from the API side. API is handled separately.
Well, I mean, LLMs have these new, like for example, this aggregated serving, LoRa support. Those, in one way or another, might require an API change, right, to express, the requirements around those types of optimizations. For example, LoRa, you might want to list the adapters that you want to support. For this aggregated serving or like splitwise, you might want to express different hardware or topologies for the prefill and decode.
Yeah, right. So there's an early version there with respect to fine tuning, but we haven't actually gotten to that particular point yet.
Yeah, Abdul, I think the LoRa support in serving, it might not introduce API level changes. I think in a lot of practice, we need the engine side to support model loading or unloading. So in that case, it becomes a control plane command to the data plane directly. So technically, we can do some registration logic instead of the API changes. But I agree. I think some of the users may bake the LoRa directly into the models instead of doing the dynamic way. So in that case, that probably needs some changes underneath there.
I mean, at the end of the day, you could think of it as like configuration. So you can provide because you want to express which adapters you want to deploy with the model server, right? So that has come from somewhere. So you either express it as something explicit on the API, or you say, okay, here's a configuration, and that configuration is some abstract, configuration that the model server understands only, and the API just basically understands how to mount it into the model server. So I agree. It might yes or might not. But if we're going towards the way where we're trying to make it more quote unquote native, support for LLMs, we may want to express those explicitly in our APIs. Just a thought here.
Right. Makes sense. I think that comes to the code design part, which part we would like to hand it over to the engine side, and which part we want to make it cloud native. Yeah, that makes sense.
And I had a question, and Dan, I think you hit this a little bit earlier, which would be both in metrics. I think there's the different model servers have different metrics. I think the Open Inference Protocol was a great example of standardization. Now there's OpenAI. What are some of the things that if we could standardize across model servers, kind of along this line, are there ways that we could, as a group, drive standardization for request formats, metrics, how LoRa is done, any other topics like that where you think standardization of the ecosystem?
Yeah, and one
key?
standardizing we are thinking about is the model storage, right? So how the model, what are the metadata and how they are storing, putting on the model storage, right? Because different runtimes may expect a different layouts, for example, Triton, it is expected you're putting model in a certain way, right? Otherwise it just wouldn't load the model. So we have been thinking about putting the adapter layer where you can define a standard, and then a K-serve can take care of all these so we can totally abstract away all these serving runtime to user. People don't need to we are using a Triton or some other runtime to serve the model, because otherwise you are just tied to that a particular. You have to know all the special bits these serving runtime specs.
And on that vein too, maybe this is a separate question, and it'd be good to talk about what we could standardize with the with something like Triton, we kind of see a wide range of use. We see people using it as a component of their larger system. So they already have an MLOps platform and they're using, Triton as just one component. Some people have built around it. They're using like the dynamic capabilities of Triton. And then there's some who just, they want a high performance model server and Triton is a detail. For Kserve, what do you see as the big, do you see some of those more diverse uses of Triton? People using it as like a model server that can support dynamism and the model packing, or do you see it more as the pre-canned model use cases?
Yeah, I think most people use Triton like for the performance reasons, right? I think low latency kind of because they have a lot download optimization, especially on GPUs. So far, like at least from our like internal like kind of feedback, like Triton is most like the performance like kind of serving runtime we have like a benchmark with. I mean, of course, there's like reasons people can't get onto Triton for like they need to build their like custom predictors. So that's where like we try to figure out a way we can like standardize these like serving a model like with you can save the model in a standardized way, and then you can like switch between like a more optimized runtime, right? And people sometimes prefer like, oh, okay, I can write like a custom predictor, which is easy, and I don't care about latency. That's totally fine. That's where like we need to come up like a standard, so I can save the model in a certain in a standard format, so I can like either deploy with the Triton or like for other people may okay, I just take this model and just run like a vanilla like a Python runtime on top of it, right? So I don't need to like save the model in the Triton format if I'm going to deploy on a simple like a Python like a predictor.
Okay. So I do want to go back to some of your original points. Anything more we want to talk about workload APIs? Any other questions in this vein or standardization? Just trying to make sure we can walk through kind of the high level topics. Okay. So I know one of the things. So I think I've seen most of the things that you're describing, Dan, from people, in using a wide range of approaches. I think on cold startup times, volumes, that's definitely something, cold startup time in general on Kube is like a rich area of interest. And so on the disk stuff, I know there's, various specific things people can do. One of the things I know that we've talked about would be like warm pooling of instances, doing things in Kube that would make it easier to, just from a general workload perspective, amortize some parts of the startup time more generally and tie that into auto scaling and capacity planning, because you can preload images, you can make sure that volumes are already attached. We're probably going to have a discussion this week about that. But are there any things in general in the cold startup time aspect that you would prefer that someone solve for you generically? Like, what are the ones that definitely you don't want to mess with? Like HPA is another example. We've had a couple of discussions about HPA being more proactive, HPA being more reactive. Like, I don't think there's anything that says that we wouldn't go improve HPA. And so that's kind of a natural place for us to discuss some of the improvements to startup time, either by amortizing it or by mitigating it. Anything in that area that you just prefer not to have to do, that you would prefer Kube to tackle for you?
I can give an example, right? In Kserve, we have a concept called model cars. So that's especially useful when you are loading large models, because especially during auto scaling. So basically, the models are saved in OCI image registry. So they only have to be pulled once for each node. and that could greatly, significantly speed up things. So,
Are you integrating directly with the container runtime, or are you keeping a separate cache there? How's that integration work?
it's basically a sidecar in case of runtime part.
Yeah.
The model runtime part.
It's basically leveraging the Kubernetes like image caching, right? Once the node port once, then it's cached there. But the concern is like, can we like sticking a large language model into the OCI image? Is that the best practice? Like it's 130 gig, right, model, like Llama 3 is like. Because each image layer has like a limit also, right? I'm not sure like if it may work like for a few gig like a model, but like for a large language model, is that that's like a kind of a concern we brought up, like, oh, can we like put the models into OCI image like for these 100 gig like models?
And I think, yeah, like I think this is one where we see a mix of people using container images, maybe less on the OCI model images, but putting large models in images, using URLs, using file systems, using distributed file systems, using just not even realizing that people with TGI are just automatically downloading huge models into empty DIRs. So we kind of see that spectrum. I definitely think this is one where we couldn't come up with like a one-size-fits-all recommendation. And so we were kind of interested in trying to find others who, what are the things, how could we reduce the number of options so that you had a set of good ones? So like, example, on OCI image registries in the sidecar, one of the discussion points we had was, well, could we just do volume mounts could we do volume image mounts that could mount a container image? That wouldn't work for really dynamic use cases, so that might not work for Kserve. But if you're having any challenges with that sidecar pull model, operationally, those would be things too. Like I know we're going to have more dynamism in Kube over the years. Kind of already thinking about if you update you can update a pod to change the container image. Maybe we could support changing the container image for a volume mount. It's not something we've done, but I think like that would be one particular area that, as an example, we could say, okay, well, what if we made managing through Kube the series of images on a node more effective? So I'll just tee that up as a potential. What else on the pooling side? Like we mentioned some HPA challenges. Oh, sorry, Peter.
Oh, you're fine. I had a question. I was just wondering, what does the folks who are currently mounting them or putting the models in the images or using them to using images to distribute models, are you doing anything to prevent garbage collection on the kubelet side, or are you just making sure the node has enough capacity so it doesn't interfere?
For us, we don't do any garbage collection as far as I know.
Gotcha. Okay.
Yeah, because I assume what you're referring to, Peter, is the if the node is under pressure, then kubelet will just go and start purging images.
Yeah, I'm wondering if maybe like, do you store the images, basically the images with the models with other the other images on the node? I guess there's two questions, because one is, if you're using OCI images to distribute the model, but not as the container itself, like embedding it in the container, then you would have to contend with this garbage collection issue. If you're just embedding the model inside of the image that the container is running in, then this wouldn't be a problem. But
I don't know what the order is. Whoever wants to tackle that question. Kai or...
Hello, can you hear me?
Okay.
Yeah, so we do have tried. So in Kaido, we do use the approach of the images. So we put large models into the images. And we have tried 130 gig images. I mean, it works, takes a long time to pull, but once pulled locally, everything runs successfully. In terms of the garbage collection, a few things it's a little bit special, especially when you deal with such a large model. Usually you have a dedicated node for that model. So you and usually the life cycle of that node is tied to the LLM workload. So you delete the LLM, so that node probably much is going to be gone because it's pretty expensive to leave an idle one. So I do see the chance you may blow the OS disk or whatever image disk for that. But I don't think at least I don't see a clear strong needs in our end to do cleanup because usually the node is gone when the LLM service is done.
Kai?
Plus, I assume you also right size the node so that it can fit the model if you're dedicating it to that anyway.
Yes.
That makes sense. Thank you.
Kai?
Hi. I have a question is that I'm working on the Kubernetes and array, and I think currently array has an experimental features that we will run a container in a container. We will run a container that in array node in a Kubernetes side is the Kubernetes part. So we run a container in container, and then we want to one container for the serving purpose. And I think this feature is mainly about that. Because we don't want to back all the models because array is very versatile and we will do a lot of things for the array node. We don't want to back all the related like a model parameter into a single array image. And we just want to pull the image that whenever we need to serve the model. So I'm wondering that if we catch the image that's in the node, is it able to reuse if I launch a container in the container?
If you're launching a container in a container, are you running a separate container engine, or are you using the host's container engine to launch that container?
Honestly, I am not pretty sure the detail, but I think we use like a podman, something like the daemon-less mechanism that in the pod.
I would suspect you would need to configure it to reuse, and there could be that. So I'll actually record this as I think this is actually a deeper topic that we actually should just go do a session on, which was like, it sounds like model distribution, common use cases. Maybe we'll run it in one of the work streams, because I think this actually is it would probably fit into the auto-scaling work stream right now, because we've got the cold start time mitigation, and I think a lot of this is about cold start. So I'd be happy to queue this up as a topic maybe for a week or so, and we could actually go and do a deep dive. This seems like a great topic.
Cool, thanks.
Who's next? Sachin?
Yeah, thanks. So with the model download, I just wanted to throw in another angle. More recently, we have started using TensorRT LLM, so it's not only the model parameters information that goes into the server, but also the engines that are built. So basically you get the model, you sort of compile some engines specifically for that, and then that also goes into the model. So interested to see, how different people tackle this same problem.
Yeah, and maybe like turn that to the K-serve team, since that's the focus. Like anything specific you're doing to deal with model code or engine code variations? I'll take that as a maybe. All right. I'll record that as no answer. If someone wants to add comments in there, it might be good to have. I don't know who's next. I don't know if there's a queue order. I can't see it. If someone knows who's next in the queue, please just speak up.
I can leave a comment. I think in our practice, we most of the case we don't bake the models into the containers. We only bake like small models, like stable diffusion models into the container, which makes the entire container less than 10 GB. So that's kind of acceptable to us. For larger models, there's a few reasons. The first reason is most large models consume the engine consume all the GPUs on the entire node. So even we cache the model, so only that node could benefit from the cache. So other node cannot. That's why we prefer like distributed cache rather than the single node cache in some of those cases. The second part is the performance. So even we cache the node on the disk is so the disk I/O performance is less than the network throughput. Yeah. So in that case, we think like loading from the network and increase the parallelism is much better than the reading from the local disk. Yeah. So that's some I think the known like performance tricks from our practice.
Okay. RP.
Yeah, I was just going to kind of like maybe elaborate a little more on that point, because that one is kind of a question and more of a comment. I've done a bit of reading around reusing EBS volumes, like multi-read EBS volumes on EC2 for this type of thing. It's more of an AWS specific, but it sounds like at least in that domain, they're using models on shared storage. And then depending upon if the volume can be mounted to the same node, EC2 node underneath, that all pods on that node could reuse the model in some way. So I think there is some more research out there. I don't know if anyone else on the call has experience with this, but basically being able to reuse a volume across all pods running on a node, that may help in terms of getting the models into the images faster. And I'm mostly like concerned around auto scaling times when serving needs to scale up, and the speed at which those pods can be started. Cold start should be pretty as fast as you can get it. And if the idea of sharing like volumes across nodes is something, if anyone has experimented with on any of the cloud providers or internally, any company
I'd say, yeah, I was gonna actually say, like, I think Jajin's point is like at the extreme scale, even disk is too slow. Like even the best disks, best file systems are still much slower than the GPU networks. I think the scale you're talking about maybe is that step below, like the distributed file system. You're getting into like cloud specific or deployment specific. And what my experience is that actually there's no one size fits all approach. It differs by the cloud and what the actual semantics of the shared file systems are. Like different shared file systems offer different trade-offs and different caching, and it actually is less about the file system than it is about what the cache hierarchy is for depending on how big your scale is. I think that step down below is what's like the low operational cost version of that, so you don't have to know all those details. And then the step below that is you just stick it in a container image or download it from a URL every time. Let's, as much as I want to keep doing this topic, I did want to finish with, since this is case specific, let's do a follow-up on image pull. We'll do it in the auto-scaling work stream, and I'll send out an invite maybe for next week or the week after, because I think this is a rich topic, and it absolutely is something we should discuss as a group. Abdullah, do you have a question?
I was just going to comment on that same topic, but if we're like,
yeah.
But just a quick comment, like there is something like this in like Google Cloud PD. You can attach them on the fly in the same zone, and we do have like something like similar to what Clayton mentioned, like some caching hierarchy that you would benefit by mounting the same PD to multiple nodes without the overhead of provisioning the PD again and again. So it gets just cloned, like in the cell, and then and it's a network attached storage, right? So as like you would get the performance of your network card basically, and should be faster than physical disk.
All right, I've added an action item for that. So to go back, I wasn't following the chat, but I just wanted to ask, there's I heard a lot of familiar things, I guess, in the K-serve angle, and I think one of the advantages that y'all have from a K-serve perspective is you're focused on this. I definitely want to find ways to split up lower level pieces that we can help with across multiple frameworks. But I also want to be I want to do it in the way that is most beneficial to the ecosystem in general, because I don't think we're gonna. I would say Cube probably isn't going to focus on model management, but it would definitely do things like supporting fast loading and better auto scaling. Maybe like to the Kserve folks on the call, are there any things that we've mentioned, metrics and auto scaling? I think we want to actively go target improvements to HPA. We want to target improvements to cold start. What about using accelerators? Is there anything from a Kserve perspective where if the accelerators, what are some obstacles you hit operationally with using accelerators? Do you have any requirements on some of the more complex multi-accelerator scenarios that we can partner with a device management working group? Are y'all bringing requirements to device management? Can we help with that and help make sure that you're represented well? What's important in that domain?
Like some of the problems that we have seen, and Dan said that earlier, it's primarily regarding the resource utilization and the amount of GPU memory used. So we have, say, in most of the deployment, there will be fixed number of GPUs. And if that is the case, how do we efficiently use that or divide these models by sharing these GPUs, etc. By default, in the current scenario, each model takes one GPU, right? So unless we have a different operator, kind of a vGPU or different slicing, it would basically take one GPU. Like, so there are, it's mostly on the device management side, on the resource utilization, how we can efficiently use GPUs.
Do you have I mean, so I will say that device management has a set of use cases around GPU sharing and things that Kubernetes should support as well for GPUs that it does for CPUs. But obviously, GPU sharing and accelerator sharing in general is a complex topic. If you have those requirements, if you have I think we'd love to help make sure those consistently show up. I don't know if Sergey's on the call. Sergey's helping drive the DRA use cases, the device management use cases for 131 and 132. That'd be a great opportunity for us to, as the serving working group, concretely recording the use cases that you'd like to see better, or, helping broker that. Especially if we need to model memory, if we want to model memory size on GPUs, there's a set of NVIDIA use cases. Can we help make sure that those use cases actually match stuff that you'd want to do? Okay, well, we got 2 minutes left. I don't know if there's any last minute areas that folks would like to follow up on.
Yeah, I wonder if we discussed the startup and cold start and warm start scenarios. I wonder if there are more pain points that Knative has in general with inference that we didn't cover. So not related to startup maybe, but like anything like super pressing that like if Kubernetes will only do this small thing, it will be much better. That kind of feedback is also interesting. And I don't know if there is any documents or any like issues that Knative already have tracking.
It's mostly on the auto scaling part. Yeah, I think we have discussed regarding that, and the monitoring as well. I think those are the two main strongholds of Knative, specifically in the serving context. There are other advantages as such as well. For example, kind of like immutable revisions, etc. But more than that, I feel that the auto scaling is more important. For example, HPA doesn't take care of most of these things. It's not well suited for the serving requirement.
Yeah, and also the Knative currently like requires like the rollout, right? It's not doing the rolling upgrade. So like it requires like if you set min replica to 3, and then it requires another 3 like GPUs to do the perform the rollout, which is very expensive.
Yeah, and,
so
and that's
we
like
actually made like a plugin to like implement the progress rollout, which is like a part of the Knative extensions. So I'd hope like if we can like get that into core Knative, so we don't have to maintain like a customized like Knative installation.
And maybe like this is a great question to ask too. Like we talked about raw deployment, we talked about Knative mode. Are there things that we could do in Kubernetes that would mean you would be less like beyond the obvious up high level? If we could make like a raw deployment primitive work really well,
yes,
what would that look like? That like I feel like that's a topic we could dive in the follow up. Like what would a primitive, instead of like y'all having to support raw deployment, that would just plug into serving class and fit naturally? Like that seems like something we'd love to follow up on.
Yeah, I would be definitely interested in that topic.
Awesome. Okay, I really appreciate everyone's time. Thank you all for this. KServe team, thank you. It was a pleasure having you here, and we want to definitely follow up. I'll work with Sergey and Jan to get like a list of follow-ups, and then we'll have another couple of orchestrations I'd like to go through and get folks from the ecosystem to also do this, and then maybe Dan will have like a follow-up and do a more direct like focus on a couple of topics and see what blows out.
Sounds good.
Thank you, everyone.
Yeah,
Thank
thanks
you.
everyone.
Thank you.
Have a good day.